Hello everyone, I am Jared Cox presenting for Group 21. My group will be discussing our Electromagnetic Field Theory project. The aim of our project was to design an antenna capable of operating in TV white space. You may ask yourself, what is TV white space? Well, TV white space is described as a range of unused frequencies allocated to broadcasting services. According to the IEEE standard 802.11 AF, this frequency ranges from 54 MHz to 698 MHz. An antenna is an electrical device which converts electric power to radio waves. There are several different types of antennas out there. However, we chose to work with the Yagi antenna mainly because it can operate at the specified frequency range. Here we have a conceptual model for this antenna shown in the figure. As you can see, it has three main elements: the reflector, the driving element, and directors. The driving element is connected directly to the feeder, whereas the directors coupled to the transmitter power through local electromagnetic fields which induce currents in them. The director elements are cut shorter than that of the driving element, which itself is a little shorter than a half wavelength at the design frequency. The reflector is cut to be about half wavelength, and it is longer than the driving element and spaced closer than the other director. The objective of this design is to make a traveling wave structure with currents in the elements all contributing to the far field in the forward direction. The contributions are designed to add up in phase in the forward direction and to cancel in the reverse direction. The antenna was built and simulated with COMSOL software. First, we had to configure the antenna with the desired parameters such as the antenna geometry, the length of each element, and the radius. Next, we chose a material for the antenna, which we chose to be copper. The antenna can be seen in the diagram shown also. We now had to mesh the antenna design. This is a way of getting the required results such as 3D plots and frequency domain plots. A few pictures are shown of the design steps. We have the 3D plot and we have the frequency domain. This picture reflects the antenna radiation patterns within the TV white space range. The electric field illustrates where the current is generated. We can see that the driving element is glowing, which means this is where the current is generated. We now have an energy versus frequency plot, which basically shows at which frequency the antenna operates best. I will now show you some plots at different frequencies. Frequency at 234 MHz, at 330 MHz, and at 698 MHz. It is noted that the plot at 698 MHz is a little different from those shown before. Recall that earlier we said our design aims to make a traveling wave structure which currents in the elements all contributing to the far field in the forward direction. This is seen in those 3D plots, unlike the 3D plots of the 698 MHz, where there is some current in the reverse direction. Based on these results, a peak performance of 234 MHz was obtained for a 4-element antenna, and for a 6-element antenna, the peak performance obtained was 376 MHz. Therefore, it can be concluded that with a decrease with measurement of the elements, the frequency at which the antenna performs best increases. This concludes our presentation. Thank you.